All right, so welcome to the ninth episode of this here fun session in coding Python. It's Python basics and then some, specifically for developers. Today we're going to cover um, test-driven development and testing in Python. Specifically, we're going to be looking at Pytest framework as the framework for testing. Pytest has its interesting quirks, not quirks necessarily, but its interesting capabilities and power-ups that I will cover as we go through various elements of it. So I'm going to turn down the tunes here and let's start. All right, so taking a look at our code. So per usual, we're going at my apologies. So per usual, we are going to ilyagodfrey.github.io/Python Learn Marathon, and you guys know the shindig here if you've been here through enough times through here. So if you want to start afresh and you haven't done anything with that, or if you kind of lost your project in Replit, so we're using Replit, you would hit this link, run on Replit, and it would start up the project in Replit for you. All the recordings you would find on this very page here. This is the beginning of the channel. There is an entire list, and every session that is playing here is being recorded and being pushed out on YouTube most of the time the same day. So there's no editing. We're doing it live even on YouTube. All right, so let's jump to Replit and kind of poke around just for a quick refresher. So we were looking at modules last time and how they work and how the folders appear and all that wonderful stuff. Right, so the nuance there is that we're actually going to be leveraging that knowledge and understanding today quite a bit, and I will poke at various things as they're going to be happening, and we'll go through them. We have a follow along instruction, so I'll jump back to the learning marathon. We have a follow along instruction here for the ninth session, and it's setup instructions, and I will walk through those setup instructions as we go through this session. Let's just open it in a new tab real quick. So testing with Pytest. So we're going to be literally walking through all these instructions, setting up these folders, and doing all this stuff with pip install. Right, so the important part again today, just so you guys don't make a mistake, commonly we are running everything by hitting the run button. Today we're going to be running everything from command line here. So we're going to be typing command lines in there and running everything repeatedly. You'll see how it plays out. It's going to be fine. It's not going to be too much typing in the command line. What we're going to do today as far as our setup, right? So let's start with what we're going to be going over. We're going to be using Pytest, and we are going to be running a fun little TDD exercise, a coding kata that is called String Calculator, that allows us to develop a function that just is going to do add, and we're going to make it more and more complex and capable of processing more and more complex add strings. So let's start by setting everything up and taking a look at the notion of Pytest. So we are going to be putting a folder structure in place to get our modules together. So I'm going to run all of that, while that instruction just tells you to create files and do all that stuff. We're going to do a little bit of Linux commands to make all of that happen for us. So first of all, we are in our console right now, so I'm just going to list all the files, right? And we have like a large number of files that we already have in this project. So the first step that that the instruction suggests is to create a source folder. So what we're going to do, we're going to do mkdir, and we're going to say src. So we're going to create a source folder. So if we do ls-l right now, we can scroll through and see it at the bottom here, right? So we made the source folder. Next thing we need to do, if you recall, when we create a module, to create a module in older versions of Python, you need to have the underneath.py file, right? Pytest is leveraging that to find the root of the project. So basically it keeps going up and up and up until it sees no longer underneath in a particular folder. Then it knows this is the module start from one level up. And so what we need to do, we would need to create a underneath file in that source folder. So we would use command, because that file is really empty. All we're going to do, we're going to call command touch. So we're going to touch, and then we're going to go src / __ init __ .py. So that's our underneath file. So if we do ls-l src, we're going to list the content of our source folder, and it's going to have a underneath file, the underneath.py file in it. So src is now officially a Python module. The other folder that we would create, and that is actually a relatively common way to structure your Python code, is you would have your source folder where your project base is going to be, and everything is going to be kind of folders from within that. And then the next one that you would create in parallel is going to be your tests folder. So that's what we're going to do right now. We're going to do mkdir tests. Let's do plural just to make sure that we're consistent here. So we're going to have that if we do ls-l again. So again, it's mkdir tests. So let's do ls-l, and we have our tests folder, right? And then the next thing we are going to do, we are going to create a underneath file in underneath.py file in tests, right? So again, we're gonna use touch because again, we're not putting anything in there. We just needed to indicate that this is the root of our test folders. So we do touch. My apologies. It's gonna be touch tests / underneath.py. Make sure you run that. So if you do ls-l, let's do. Okay, this ended up being weird. So let's do ls-l, and let's look through, make sure you didn't end up with underneath.py file here. If you did, just do rm _init _.py. Right, so I just wanted to make sure that, so I don't have anyone, but if you created one by accident, this would get rid of one. Okay, so let's run history real quick just to see. Come on, run. Okay, just to see all the commands that we ran real quick. So we have our make directory source that we made out of root. Then we did touch source / underneath.py. Then we did make directory tests. Then we did touch test underneath.py. Then we did the removal in case we did a mistake there and created it locally at any point. And so off we go. So let's look away from this and look at the actual folder structure. So what we ended up with here, we ended up with test folder that has the underneath.py file, and we ended up with source folder that has the underneath.py file. So it's important to make sure that we have those folders. I didn't want to create them on the left side here just so that you guys don't end up getting confused with folders and subfolders and some other kind of nonsense. Just so the lineup is clear, it was easier to do it in command line here. So now we have the structure in place. Next thing that we need actual Pytest to run everything. So we're going to go to our good old friend pip install, and my screen froze. So I'm going to do good old reload to make sure that everything comes up. Luckily, it retains the state of the folders here, so we're good. So what we're gonna do pip install Pytest. So that is the package we're gonna be using to run our tests. So if we were to run pytest tests right now, that's our command. So we're running pytest tests. What we're telling the pytest now is a command that we can run out of a console, and when we run tests, we are going to be running everything that's contained in the test folder. So let's hit enter here, and there's nothing to collect, so no tests ran, but pytest is in place, and it's the tests folder, so we're good. Okay. So here we are, we have this stuff set up. So we are going to have this fun thing that we're going to add here. We're going to set up our next, we're just going to close the modules. So we're going to set up our next project in the following way. So let's do this. Let's make those two files we're going to be working with in console as well, just so that again we don't get lost with folders and everything else. So let's go on console. Let me just zoom in here, and we are going to make a calculator.py file in our source. So we're gonna do test, and I'm sorry, what am I doing? It's gonna be touch, and then src folder, and it's going to be calculator.py. So we're gonna make that in our source folder, and then we're going to create touch tests. So important part about creating a test file. A test file is a Python file that either needs to start with test underscore or end with underscore test. So we're going to call it calculator underscore test.py. So that comes from kind of the convention over configuration type of thing. So if there is a file that doesn't start with test or end with test in a test folder, Pytest is going to ignore that file. And you can leverage that file anywhere else, but Pytest itself is not going to try to open it and look for tests inside of it. It is just going to jump over. So a file either needs to start with test underscore or end with underscore test for that. So now we created those two files, and that's going to be our playground. So let's zoom out and take a look at that. Again, we have source. In source folder, we have calculator.py. In test folder, we have calculator test. And for some weird reason, I lost .init in my test folder, which is not great. Looks like reset did not work out very well. Okay, so I'm just going to do real quick touch src / .init.py. Okay, let's do that. Let's see if I refresh this real quick. This is really strange. Why am I not seeing it? All right, let's do ls-l src. Because it's src, not tests. My apologies. It should be in tests. So it's touch tests / .init.py. Rerunning that. Okay, now that is there. I guess my reboot did something to this whole shindig. All right, so that's fine. Those .init files just need to be there. They don't need to do anything else. Okay, so we have this set up. We have these two files set up. So now let's do pytest tests. It's just going to run through it again. Again, there's nothing to collect. There's nothing to do. But we just have it running. Everything is okay so far. So the next thing that we're going to do, we're going to do this kind of lazy exercise for ourselves. We are going to actually enable our Pytest check and follow the code base so that we can consistently watch tests as they let the rings repeat. So whenever we make modifications to a file, they get saved and the tests would get rerun over and over for us. So for that, we're going to install another package. So the package we're going to install is pip install. It's going to be pytest dash xdist. So pip install pytest dash xdist. Let's run that one. It's going to jump through a few hoops. So it's pytest pip, sorry, behind default here, pip install pytest xdist, right? So that was the command that we ran. So the cool part now is that we are going to run the next command that is going to allow us to follow all the files that are involved in this interaction here, and just tail all the changes and rerun tests as we make changes. So the command that we're going to run is pytest -f for follow tests folder. So let's run that, and now it's watching as we make modifications to our stuff. Okay, so basically whenever we're going to make modifications that get saved out, it is going to rerun those tests. All right, so let's go and actually start setting up what we're going to be working with. So we're going to be creating a calculator, a string calculator. The idea is that it's going to be a function add. So let's define function add, def add, that is going to take, see, it keeps saving and rerunning. So it's going to define function add that is going to take a single parameter that's going to be a string. So let's call it values. Let's do annotation because we know how, right? And right now we're just going to put in pass so that we have complete piece of Python code. See, it just keeps on churning over to the right side and running whenever we do it because REPL, it just keeps saving the files. So one of the things I haven't mentioned when we were covering functions is that you can create an empty function. The way to define an empty function is to put a no-op keyword pass inside the function in order for it just to be present and to be fully defined, right? Because if you just put first line in, it's not really going to do anything. You really need to have a second line here to for the function to be fully defined, and that second line, which is no operator, is pass. All right, so we define this add function, and let's do our test-driven design, right? So the first test in our test-driven design is going to be, let's go to calculator test and let's set everything there up. So in calculator test, we're going to be testing our add function, right? So what we're going to do here, we're going to go and say from src, right? That's our module, calculator import add. So we're going to import that there, right? It's just, this thing is like throwing errors because I don't know how to type and it constantly saves, but it's cool. All right, so we imported add, which is our brand new function that we just added to the other side. So the next thing that we're going to do, we are going to write our first test. So the way we write tests in Pytest, in Python file that will be run by Pytest, we define a function that has to start with test underscore. So that is second convention in Pytest, is that a function has to start with test underscore in order to be included in test suite and actually be ran. So we're going to define test underscore. So the first one we're gonna do is we are going to call this with an empty string. So we're just defining a function, not passing any parameters to it, right? It's gonna be screaming that the test is incomplete because we haven't provided anything in it. So the first one that we're gonna try to do, so let's just put pass, right? So it stops freaking out. And it's really gonna be test passes because nothing really happens, right? So what we're going to do here, as we structure our tests, as far as structuring our test goes, there are 3 A's that go into building a test, right? So the first one we're going to put in comments is arrange. That's where we set up all our prerequisites, staging our data, doing all kinds of stuff. Then act, which is ideally a single liner that actually performs an action we're testing. And the third one is going to be assert, right? So I'm going to be very kind of prescriptive on how I'm writing this. Obviously, this test can be considerably shorter, but I'm just going to put all the elements in there to help you along. I'm going to zoom in because this thing I see on the screen is not terribly visible. So first thing that we're going to do, the first assignment that we have in the description is when I pass empty string into add function, it returns 0. So let's create the first parameter, call it in val, and we're going to set it to an empty string, right? So that's going to be our range. We have an input value that we're going to have there. And let's create another variable called expected, and we're going to set it to 0. Then act. Act is actually calling an add function to get a result. So we're going to create actual, and we're going to set it to add in val. Okay, so we did that. And then we are, right, so there's nothing particular, it's plain Python, there's nothing particularly magical in here. So the next thing that we're going to do, we're going to dump this pass here. We are going to actually run a keyword assert in here, and we're going to say expected double equal actual. And all right, let's just hit new line. Let's zoom out and let's see what happens on the right side. All right, so we have, this is our first test. We have something cool and important happening here. We have created a test. In that test, we arranged our values. We did an act, which is just calling this item out. By the way, I mean, these comments are literally just comments to break down how you put together a test-driven design test, right? And then, so we have an act, and then we have an assert. So assert, we use the keyword where, we have expected value equal actual, right? So you guys are staring at it, there's nothing magical about that. So what do we have here as an output? We have as an output a statement that we have an error, right? So our test failed, first of all. So we run 100% of tests, our test failed, and we have an issue where assert 0 equal to none is not working, right? So our expected value was 0, our actual value is none. Well, the reason our actual value is none because this has only pass at the end of that function. It doesn't truly return anything. So the cool part to know about Pytest is that assert is just a keyword value in Python that throws an assertion exception when the statement is not equal to true. Pytest actually wraps that capability and fetches this, fetches the content of the assert statement and gives us more detail. We don't see that much in this particular, particular exception here, but it really does a wonderful job as you grow this out. Because normally, if you look at the testing frameworks, you have all kinds of assertion frameworks that go along with it that, throw exceptions, catch exceptions, provide, elaborate messaging. Pytest really ties into capability of Python to just run assert message, and it reads intelligently into that. And if you have more complex comparisons, it would give you more elaborate details on which parts, like which lists are different, which values in dictionaries are different, whatever. So it's really cool. Okay, so we have this first test. So now, in the true spirit of TDD, test-driven development implies that you first ask a question that produces fail, right, against the function that you're trying to modify. And then you go and modify the function to ensure that the test that it's running is passing, right? So that would be your first, that's your red-green refactor. So you make it red to ask the question you're looking for, and then you look for green to get the answer. All right, so let's take a look now at our calculator, right? So we're going to be hopping between those two. So in our calculator, we're just returning a pass. So if you think about it, when we pass in an empty string, what would be the simplest, dumbest answer we can provide to satisfy the test? Because the test says when you pass an empty string in, my expectation is that I get 0 back. So I'll let you guys think about it for, maybe 30 seconds kind of to figure out what would be the return statement that you would put in here that would give you what you're looking for. All right. 30 seconds is not enough to turn the tunage on, but I'm going to drink some water. That's what I'm going to do. All right. So the silliest answer that we can provide here, because TDD requires you to do just enough to make things work, the silliest answer is going to be return 0. Right? That's all we're looking for. So it's going to rerun it right now. Ta-da! Test is passing. Phenomenal. So the next thing that we're going to do is go after the second task. So the second task, when I pass string with 0 into add function, it returns int 0. So let's go to calculator test and let's write a new test that says define test 0 in string. We're going to open close parenthesis, put pass, so it stops freaking out. All right, so let's make this test. Let's make this test red first, right? So what we need to do, we need to put in our input values, right? So let's go in val is equal to 0, string that contains 0 in it, right? And our expected is 0. And then we're going to do actual equals to add in val. So we're not really adding anything yet, right? We're just passing a single string in. And then we're going to do assert and do is the same thing, expected equal actual. So much to our chagrin, even though we want to do red-green refactor, because in both cases we just return 0, we get a 0 back. We don't really need to modify anything, right? We got 0 back for both cases, so this stays green. So the next test we're going to go for is this. It's going to be when I pass a string with a number into add function, it returns the number as int, right? So let's do define test number in string. So what I would like to do now, I'm just going to put pass for now just so that it doesn't scream. What I would like for you to do right now is to actually write that test, right? So I'm hoping that you are kind of catching on to what we're looking for. And so I want you to set up the test real quick, and then I'm going to follow on with my steps of setting up the test. So the expectation is that basically your input value is going to be a number of some sort. Single character, multi-character, whatever you want. All right, so I'll give you another 30 seconds to go through that, and then we'll
open the Twitch chat.
We'll put that really quickly in.
In case anybody has questions. No?
Yeah, no, it's fine. So yeah, so we have this little beast over here. Go and make in value not an empty, not a 0, something else, and then write what you expect, and let's put that test together. All right, so hopefully this part was sufficiently straightforward. Let's go. So we're gonna do in val is equal to 42, because of course it is 42. Expected 42. actual is equal add in val assert expected equal actual, right? So let's zoom out and rightly so expect this test to fail, right? Because 42 is not equal to 0. So let's go and fix this thing. So the simplest thing to return to address that particular test is going to be, other than returning 42, is going to take, so if we go 42, right? Let's go start with that. So we go 42. That, makes the last test over here pass, but it breaks all the other tests, right? So in reality, we need to convert numbers going in into integer. So we're gonna do int values. Let's start with that. So that's all great, but that fails our very first test and causes an exception value error, because invalid literal int with base 0 when you pass in an empty string. So what we could try doing is if not values return 0, right? Kind of jumping ahead as far as I wanted you guys to honestly solve that, but so what we have done here, right, we have checked our values for truthiness. We'll have plenty of other ones to solve. Sorry, I got carried away here a little bit. So what we're doing here, we're putting an if statement. We're checking values for truthiness, right, meaning that if values comes back as an empty string, it's going to be set to false. So if value is false, if not values is true, and therefore we just return 0. Otherwise, we convert that value over. So let's look at the next test. So next test is where it gets truly complicated. Let me just zoom in real quick to show you guys what the code was. And for the next test, what we're going to do, we're actually going to now go to the power of this string calculator. So the key for that string calculator is to pass in a number, a set of numbers in a string separated by commas. So we're going to do 25, 3, 17, 49. And the idea is that our add calculator is actually going to break that string up, grab individual values, add them up, and return a result, right? This is where things get really messy. So we really started with like very edge cases of like various inputs that are nonsense, and we did provision for that, and now we're actually going for the meat of the deal, right? So that's what our add calculator is set out to do. So let's do the first thing. Let's write the test for it. So I'm going to just define test, right? So it needs to start with the word test. Multiple numbers can go in string, that's fine. However you want to name it. I'm going to put pass on that. And so what I'm going to do is I'm going to do the same thing again. I'm going to give you guys a minute to write up a test, and then I'm going to follow on and write up a test, and then we're going to jump over to the function and actually start thinking through what we need to do there. All right. So let's go for a quick minute of writing here. I'm just gonna zoom in so you guys see the previous and the current. And so remember, we are looking for a string with comma separated values. All right. Let's go for a little bit longer. 20 more seconds to get this thing typed up. And then I'm going to follow on with that. So as you would expect, the only real thing that would change here is going to be the input value and what we expect as an output out of that, right? So let's go put that together. So we're gonna go inval is going to be equal to let's go 42, 25, 17, 3. We have expected. I'm going to be lazy here because I don't want to be adding it by hand. I'm gonna go 42 plus 25 plus 17 plus 3, right? It should add up literally. And then we're gonna do actual equal add inval. And then we're gonna do assert expected equal to actual. Right, so that's our test. And obviously our test here is losing its mind. Well, yeah, so now that we ran it the last time, we actually don't even have the test passing or failing. We're getting a straight up exception in that test as expected because it says invalid literal for int with base 10 where you have commas as separators in this setup. So what in the world are we going to do? Let's jump over to the calculator. So now we need to modify this function here and do the whole hard work that we've been learning about so far. So the few hints that I'm going to give you, you're going to need to use, you're going to need to split the string, and you're going to need to iterate through that string, and then you're going to need to add everything up, right? So let's do that. And I'm going to give you guys another minute. Just try to take a swag at it and see what we want to do with this, and then we'll actually there are actually a few iterations. We'll start with a simple straightforward one, and then we Pythonize the live out of this. So let's go for another like 40 seconds just so we don't have too much dead time in here to try to break this down. Yeah, so think about the way the values come in, what that string looks like, and what we need to make of it. Something's loading there. All right. So let's think through. Let's start with what is that we actually want to keep around, right? So our check for empty string should remain, right? We want to stick with that. The other thing that we're looking for is we ultimately want to end up somehow with, if we have a single number going into that list, we're going to return that single number in there. But let's kind of mess around with it and put some modifications. So I'm going to go after return 0, right? Make sure that we're at the level of if statement, right? So that, you know, if statement executes, we return. Otherwise, we continue executing, right? The scope with if statement, everything is quite important. So the next thing that we're going to do, we are going to take our values. We're going to separate them into a list of values, right? We're going to separate them on comma. So let's go do let's go like values list, score list, right? So just something like that to be a little bit clearer for us. And we're going to go values sorry, values.split, and we're gonna split it on comma. Let's do print just to see what comes out of it. Let's see if this plays out for us. Trying to remember if it's gonna actually print. Oh, did we? Ah, we reloaded and it crashed. And I don't have. Okay, so I'm going to do the following. It crashed unfortunately on my side, so I'm gonna go Pytest -f and then tests. Let's go -s and -v. So this is going to output our print strings, and it's going to be verbose. And it doesn't even find Pytest. Whoa, we really restarted here. Okay. Pip freeze. Sorry, I'm just this thing really crashed out on me. Nope, nothing. So okay. Lovely. Pip install Pytest. Fortunately, I have to redo all this here just to get all the packages back. Yeah, sometimes, like, you know, free has its moments, right? All right, and then pip install Pytest x dist. So these are the two packages we need to install. I actually could have just chained them, but it's okay. So I'm going to install both of these again, and then we're gonna do Pytest test. Luckily our work is still around, so we do Pytest -f tests, and then let's go -s and -v. So it's gonna be s is gonna output strings that we're gonna print, and -v is gonna be a bit more verbose. Let's run that. You better work. Wonderful. Okay, so so what we did here, we printing all this values out, right? So we ran the first one. So first one passed because it just exited at 0, right? The second one, 0 string, so it created a list with just one number, which is 0. And then we created the second one, which is with one number, which is 42. Interestingly enough, both of those passed when we just when we get values, right? So it's fine. It still passes value through. It doesn't look at value list. And then the last one actually split it into 42, 25, 17, and 3. So this is cool. So we have the last one, right? We're just doing print out here, printing out what we ended up with in values list. So the next thing we want to do, right? We want to walk through all of that, and we want to add it up so that we can return it. So we can do something like we can put a for loop in there, right, to work through it. So we can do for v in values underscore list, right? So we go and we're going to do, so we need the result, right, that we return ultimately. So let's do this. So let's go result equal to 0, and then we go for v in values list, we're gonna go result plus equal, and we're going to return particular v into int, and then in here, instead of int values, we're just going to return result, right? So that's kind of cool. It should rerun, and all of it passes, right? So this is beautiful. This is very nice. We have this, you know, we print our values, we walk through each one of these, but it is solved like it would be solved in any other language, right? So we want to have it to where we make it a little bit more concise, a little bit more around Python. So the cool part about TDD is that you have all these tests, right? You have all this stuff set up, and generally about having tests is the fact that you can actually go in and do a heavy refactor, and as long as your tests pass, your function does exactly the same stuff. Right, so let's do the first thing. Let's think of this. So we have this values list that we turn into a variable. So we can do something like, hey, do we have to really make a separate variable out of this? Or could we just really pass it into the for loop here, right? So what we're gonna do here, I'm just gonna grab this guy. Doesn't let me cut for some reason. Because I'm hitting the wrong keys here. I'm on Mac. All right. So we're gonna dump this guy and we're gonna just put it here, right? And then we're just gonna remove this line here. So let's go. We remove this line here. And still passes, right? So we didn't create a separate variable. We just dropped it into the in statement. But then what we do here, we make this list. We convert each individual one in there. There was this wonderful thing of list comprehension. Do you guys want to try to do it with list comprehension yourself, since you have done the list comprehension relatively recently? So I'm gonna let you play with it for about a minute or 30 seconds or so, and let's see if you can figure it out, and then I'm going to take a stab at it. I'll tell you one thing. There is a magical function called sum. There's nothing particularly magical about it, but it will ingest a list and sum up all the values in it, granted that they are of some form of numeric value. That might change what you're able to do here a little bit. Right. I really should have had some music in the background, but it's too much shuffling to get that set up, so I'll let you guys code in silence while I'm talking, so it's not really silence. All right, let's take a look at this thing. We are going to now aggregate all the values in a for loop using list comprehension, right? So let's start writing that. Literally what we're gonna do, just put square brackets around for loop, right? And then, as you remember, right, we can extract v out of here. Okay, let's drop this madness. So we got this result equal to this, equal to that. So what we're gonna do, we get a v, right? Pulled out of that. This is gonna return nothing, or result, it's gonna fail most of the time. So we have our v, right? Well, v is string, it's not an integer, so we're going to convert it to integer, right? Well, we need a sum of this whole thing. So what we're going to do, we're going to say sum, and we are going to close the parenthesis here, and then we are going to return this, and we are going to get rid of these two lines. And now, ladies and gentlemen, we have Python. So what we have done here, we have grabbed our values, we split them by a single quote. We grab that list, ran it through a for loop inside list comprehension. We convert every single value into integer, and then we ran a sum of it and we returned it. And so now we have this wonderful thing passing, which is really cool. Yeah, and the best part about it is that we have this to show that our conversion from easily readable written in any language expression to this rather Python specific expression did exactly what we expected it to do, right? Because we have our test coverage for all those cases. All right, so we have two directions we can go, and we have 10 minutes to cover this. So what I want to do, the other direction to go is actually a fun continuation of the kata. And in fact, that's probably a fun exercise for you to do on your own. So I'm just going to leave you with that, and then we are going to show how we could have potentially shrunken this suite of tests by parameterizing our call. So let's do this. I'm going to drop in here the request for the next possible, and it's in examples. It is the last element in examples. I'm just going to drop it in here, and sorry, I'm going to drop it in here and leave it commented out. And so here's the request. When I pass a string starting with a delimiter character followed by // then the delimiter character is used instead of comma, and I get back an integer sum of numbers. So that means that if I go, say, colon / 42 colon 25 colon 17 colon 3, it is going to now go, and instead of defaulting to a comma, it is going to say, hey, the first delimiter that you indicated you wanted is colon, and so I'm going to grab that, and I'm going to take the strings and I'm going to separate it by colon, and then run it as an add for that. So I'll let you set up the test, I'll let you set up all of that. What we're going to look at next is actually parameterizing calls, because the idea is that ultimately if you look at this test, right, all we have is an in value, right? Oftentimes tests with setups are like very different, dramatically looking in different directions, whatever. What we have here is relatively straightforward. You have your input value, you have your expected value, you run the act, and then you do actual versus expected. So ideally we would have something like that, where we can go test, add, and then you go something like inval expected, and then you run your test here, and it ends up working, right? It ends up you just iterate through the input values and expected values, and it works. So you absolutely are capable of doing that, and there is a call in Python called parameterized, and we are going to go through a couple of concepts of how it actually gets applied here. So we are, first and foremost, let's go to the top just so that we have all our imports on top. So we're going to import Pytest. So this time we're importing Pytest directly into our test, right? It's going to be complaining about the structure of this because we're not really doing anything meaningful with that. So the next thing that we're going to do, we're going to figure out how to use parameterize. So just so that it's a little bit more readable, what I'm going to do is I'm going to create a list of parameters I'm going to pass in. So if you remember your positional parameters from the function setting, you had positional parameters when you do star args, right? Single star args. It is a tuple. So the idea is that you are passing in a tuple in order to positionally pass values into positional parameters. So what we're going to do here, since we want to parameterize these two values, in value and expected value, we are going to make a list of tuples, which are going to be those parameters we're going to be passing in. So we're going to be, let's go with params as just our variable that we're going to define outside here. And we're going to define a list, right? And list is going to contain tuples of two values. So let's just hit new line. So the first test we had, it was an empty string that resulted in 0. Okay, so we put that tuple in. Let's put in comma. I'm going to zoom in so you guys can have easier time viewing it. And plus that the right side is going crazy right now. So we have this, right? So empty string is equals 0. Then we have a string with 0 in it is equal to 0 as well. Then we have a string with 42 is going to be equal to 42. And then we have a string with what was the values that we had. 42 comma 25 comma 17 comma 3 is going to be equal to, I'm going to be lazy here again, 42 plus 25 plus 17 plus 3. Right, so it's fine, it will add for us. That's why it does what it does. So that's cool. So we created params. Now, how in the world would we pass it here? So we're going to use a very powerful construct in Python that is called decorators. So depending on how the whole thing plays out, I will do a separate lecture on how to build decorators. So decorator is kind of the interesting construct. You know of them in Java as annotations. You know of them in .NET as annotations. In Python, they're called decorators. And so this is part of AOP, which is aspect-oriented programming. And this is where you can take any particular function and you can wrap it into some functionality that precedes it or follows it, and that is capable of passing parameters into that. So let's go and do this without further ado. So it's going to be at Pytest dot mark dot parameterize. I believe that's the right call for it. Let's see where I had that. Yep, so we have parameterize. Okay, so what's happening here is we're creating a decorator. We're not creating, we're calling a decorator that is going to wrap our test into certain values and give us certain capabilities. So the first parameter in parameterize is allowing us to indicate which variables we're going to be passing those values in. So the first one we're going to call inval, and the second one we're going to call expected. Right? These are the values that we have below. And then the next thing that we're going to pass, normally it expects list of tuples, but we declare that list of tuples above, so we're going to call params in here, right? And so all is great. This is running, this is passing because we're not really calling anything here. But the next thing we're going to do, so we have our inval and expected, right? So the setup, the arrange part is literally done in this part here. So next thing that we're going to do, we're going to say actual equals add inval. And then next call we're going to make is assert expected equal actual. And so it's going to be double equal because it's a Boolean expression. My apologies. All right. So here we go. So the entire test suite that we have written above, we have just rewritten in this form where we have individual params put in this list of tuples, and we take an individual test run, we pass in two values, inval and expected. We put in decorator pytest.mark.parameterize, pass those two in with our list of potential params, and it just runs all these tests, right? And so we literally ended up with double the input because we have all these individual ones, and then we have test add that has all these values in. The output here looks a bit weird, but whatever. Yeah, so that's kind of the play. Pytest has, we haven't touched here on, we haven't touched here on mocking. Mocking is absolutely crazy in Python. Fortunately, we cannot cover it in an hour as we just gotten through this stuff. And so I'm going to wrap it up for now. Parameterizing, is a very potent thing, and we have been just testing a pure function, so we weren't mocking anything internally, we weren't overriding anything internally, but mocking is actually very easy in Python. So I will close up on this particular exercise, and we're going to turn on the tunes to fade us out. And thank you very much. And I will see you later.